Deep inside the dense, unexplored canopy of the Amazon rainforest, an invisible chemical weapon is altering the laws of biological survival. It doesn't slash like a claw. It doesn't crush like a jaw. Yet, it inflicts an agony so intense that it forces the world's most voracious predators into an instant retreat. This weapon is capsaicin. It's the active compound that gives wild chili peppers their blistering, searing heat. For millions of years, these plants have engaged in a brutal subterranean arms race against extinction, evolving a defense mechanism designed to trick the nervous system of any mammal into believing it's being burned alive. But how did a stationary, brainless organism develop a highly targeted compound that selectively strikes the pain receptors of specific predators while leaving others completely untouched? The answer to this evolutionary puzzle stretches far beyond a simple burning sensation on the tongue. When an animal bites into a wild Amazonian chili, the capsaicin immediately binds to a highly specific protein called the TRPV1 receptor. In nature, this receptor acts as a thermal warning system, telling the brain when temperatures have reached a dangerous, tissue-destroying threshold. The chili pepper doesn't actually cause a chemical burn. Instead, it hacks this biological alarm system, sending an urgent, deceptive message of extreme heat directly to the brain. This creates an immediate sensation of panic and physical torment. Yet, that should have been impossible for a simple plant. It raises a deeper, more unsettling question. Why would an organism expend vast amounts of metabolic energy to create a defense system that only targets certain creatures? Evolutionary biologists studying the Amazonian undergrowth discovered something that seemed to contradict the basic rules of survival. While a wild boar or a rodent will flee in agony after a single bite, several species of vibrant tropical birds can consume these exact same blistering peppers without showing a single sign of discomfort. To a parrot or a toucan, the world's most potent wild chili tastes completely neutral. But researchers soon discovered something even stranger. This selective immunity baffled scientists for decades. If the plant evolved this chemical weapon to protect itself, why did it leave a massive, gaping loophole for avian predators? The mystery deepened when botanists analyzed the digestive tracts of different rainforest animals. Mammals possess heavy, grinding teeth that completely pulverize the delicate seeds of the chili pepper during mastication, rendering them sterile and incapable of reproduction. If a mammal eats the fruit, the plant's entire genetic lineage dies right there in its jaws. But what researchers uncovered next would completely redefine our understanding of plant intelligence. Birds don't have teeth. They swallow the wild chilies entirely whole. Inside their digestive systems, the flesh of the fruit is dissolved, but the sturdy seeds pass through the stomach completely unharmed. Even more surprising, the transit time through a bird's digestive tract is perfectly timed to allow the creature to fly miles away before depositing the seeds back onto the rainforest floor. The plant wasn't trying to defend itself against everything, it was actively selecting its own distributors. By creating a chemical barrier that causes excruciating pain to mammals, the chili pepper successfully preserves its seeds for the one group of animals that can guarantee its survival. The heat is a targeted security guard, filtering out the destructive consumers while rewarding the perfect evolutionary partners. But this calculated filtering system didn't mark the end of the war. It turned the Amazonian undergrowth into an active biological battlefield. While birds safely scatter the seeds across vast distances, they're simultaneously triggering an aggressive counter-strategy from the very mammals the plant locked out. In the dense ecosystems of the Amazon, no defense mechanism remains absolute for long. As the chilies grew more potent, certain specialized mammalian predators began to alter their own behavior to bypass this toxic barrier. High-resolution trail cameras and field observations captured small nocturnal rodents doing something that should have been physically impossible. They were chewing through the outer layers of wild chilies, carefully avoiding the internal white placenta, where the capsaicin concentration is highest. This unexpected behavioral adaptation proved that predators were actively studying the plant's architecture to steal its nutrients. The stakes of this hidden warfare were rising rapidly. If these mammals could find a way to eat the fruit without destroying the seeds, the evolutionary pressure on the plant would shift once again. Scientists began collecting tissue samples from these resilient rodents, wondering if a genetic mutation was allowing them to desensitize their own pain receptors. But the real mystery was only beginning. The genetic data revealed a complex molecular battlefield. In some isolated pockets of the western Amazon, researchers found populations of tree mice that possessed a subtle variance in their TRPV1 gene. This tiny mutation slightly altered the shape of the binding pocket where the capsaicin molecule attaches to the receptor. The chemical weapon was losing its lock-and-key fit. The mice were still experiencing the heat, but at a heavily muted intensity, allowing them to tolerate the pain just long enough to consume the high-energy seeds. This discovery sent shockwaves through the botanical community. It meant that the plant's ultimate weapon was driving the rapid evolution of the very predators it was trying to escape. If the rodents successfully adapted to tolerate the maximum heat a plant could produce, the entire wild chili lineage could face sudden extinction. The defense mechanism had to escalate, or the species would vanish. To understand how the plant fights back, field biologists set up automated monitoring stations deep within the Ecuadorian rainforest. They wanted to see if the wild chilies could dynamically adjust their chemical output based on the level of threat they faced from local predators. What they found altered our perception of botanical survival forever. The plants weren't producing a static amount of capsaicin. When a bush was repeatedly attacked by seed-destroying mammals, it began pumping significantly higher concentrations of the toxic compound into its developing fruits. The chili pepper was actively monitoring its environment and increasing its weapon production in real-time response to predation. But how could an organism without a central nervous system calculate the severity of an environmental threat and orchestrate a complex biochemical counterattack? But the evidence told a completely different story. Chemical analysis of the surrounding soil provided the missing link. When a chili plant is wounded, it releases volatile organic compounds into the air and through the shared fungal networks beneath the forest floor. These chemical signals warn neighboring chili bushes that a predator is in the area. Upon receiving the warning, the surrounding plants immediately begin ramping up their own capsaicin levels before the predator even touches them. The entire patch of jungle transforms into a synchronized, hyper-potent minefield. This collective defense system seemed impenetrable, but nature always finds an exception. As scientists pushed deeper into the remote river basins, they encountered a bizarre environmental anomaly that disrupted this entire chemical communication network. In areas with high humidity and dense fungal pathogen activity, the wild chilies were suddenly dropping their capsaicin production to almost zero. They were willingly disarming themselves in the middle of a war zone. This made absolutely no sense. Why would a plant abandon its primary defense mechanism in the very regions where life is most competitive? The answer lay buried deep within the plant's internal trade-offs. Producing capsaicin requires an immense amount of nitrogen and water. In the dark, waterlogged soils of the deep Amazon, another deadly threat looms over the wild chilies: predatory fungi that attack the seeds from the inside out. Laboratory testing revealed that capsaicin actually slows down the growth of certain microbial pathogens, but it also thins the protective coat of the seed. In wet environments, the threat of fungal rot is far more lethal than the threat of hungry mammals. The plant is forced to make a calculated evolutionary choice. It must divert its limited resources away from fighting mammals and allocate them toward building thicker, water-resistant seed coats to survive the microscopic predators in the soil. The wild chili is constantly playing a high-stakes game of balance, measuring the danger of being chewed alive against the danger of rotting from within. Every single geographic population of wild chilies has fine-tuned its chemical recipe to match the specific threats of its exact coordinate in the jungle. It is a shifting, living map of conflict. But as the climate of the Amazon basin begins to experience rapid, unprecedented shifts in moisture and temperature, this delicate equilibrium is beginning to break down. The predators are moving into new territories, and the plants are struggling to recalibrate their chemical weapons fast enough to match the pace of change. Long before modern science began mapping these genetic anomalies, early human populations inside the Amazon basin had already realized the terrifying potential of this botanical minefield. Archaeological excavations along the paths of ancient river tribes suggest that humans were the first predators to successfully tame the wild chili pepper. But they didn't just use it for food. They weaponized it. Thousands of years ago, pre-Columbian warriors discovered that burning large quantities of wild chilies created a thick, suffocating smoke that could incapacitate entire enemy encampments, attacking their respiratory systems with microscopic chemical clusters. This prehistoric chemical warfare highlights a bizarre twist in the plant's journey. An organism that evolved to terrify mammals ended up being propagated across the globe by the most dominant mammalian predator of all, humans. When European explorers first penetrated the Amazonian canopy, they recorded encounters with native defensive walls, made of dense chili bushes, planted deliberately to deter invading forces. The smoke from these burning barriers caused temporary blindness and violent coughing fits, buying the tribe's precious time to strike. It was a flawless demonstration of nature's defense systems being repurposed for human strategy. But this human intervention completely disrupted the natural evolutionary balance. By taking the chili pepper out of the dark, competitive undergrowth, and cultivating it in massive, controlled fields, humans effectively paused the arms race between the plant and its native jungle predators. In agricultural settings, the pressures of natural selection were replaced by human preference. The plants no longer needed to balance the threat of mammalian teeth against the danger of fungal root rot, because human farmers were manually managing the soil and eliminating competing organisms. Yet, out in the wild, away from the protective hands of human civilization, the subterranean war never stopped. In the unmapped coordinates of the Western Amazon, the biological pressure has only intensified. Recent scientific expeditions, tracking the movement of nocturnal mammals, have observed a terrifying escalation. As forest degradation forces different rodent populations to crowd into shrinking habitats, the competition for food has reached a critical tipping point. The tree mice that once avoided the internal placenta of the chili are now developing highly specialized liver enzymes capable of breaking down toxins faster than ever before. This biochemical adaptation means that the rodents can now digest the maximum amount of capsaicin that a wild bush can naturally produce. The plant's primary security guard is being completely neutralized by the predator's internal filtering organs. To survive, the wild chili lineage has been forced to enter a phase of erratic chemical mutation. In certain areas, plants are beginning to combine capsaicin with secondary defensive proteins that cause severe digestive distress, bypassing the rodent's liver adaptations entirely. It's a double-layered trap that demonstrates the terrifying fluidity of botanical defense networks. But the real crisis isn't happening within the genetic code of the plants or the predators. It's happening in the environment itself. The sudden violent shifts in moisture and temperature across the Amazon basin are destroying the communication networks that these organisms rely on to survive. When a forest patch experiences extended periods of unprecedented drought, followed by catastrophic flooding, the soil's chemistry is radically rewritten. The subterranean fungal networks, the very pathways the plants use to send early warning signals to neighboring bushes, are beginning to collapse under environmental stress. Without this shared underground warning system, individual chili bushes are being left completely isolated. They can no longer warn their neighbors about incoming mammalian attacks. When a predator strikes a bush today, the signal stops at the roots. The surrounding plants remain completely unaware, leaving their chemical defenses at baseline levels until it's far too late. The synchronized minefield that once protected entire hectares of the jungle floor has been shattered into disconnected, vulnerable individuals. The plant is losing its collective intelligence. At the same time, the shifting climate is altering the migration patterns of tropical birds. Parrots and toucans, the plant's chosen genetic distributors, are moving higher up the mountain slopes to escape the intense heat of the valley floors. This leaves the wild chilies stranded in the lowlands, with fewer and fewer partners capable of spreading their seeds safely. With the birds disappearing from the lower canopy, the plants are becoming increasingly dependent on the very mammals they spent millions of years trying to fight off. It's a tragic evolutionary breakdown, where the weapon is outlasting the system it was built to protect. The ultimate outcome of this ancient chemical arms race remains entirely unwritten. Each discovery reveals that the wild chili pepper is not a passive piece of fruit, but a sophisticated, adaptive combatant utilizing advanced biological warfare to manipulate the animals around it. Yet, as the environment shifts, we are left to wonder what will happen when the mutations of the predators finally outpace the chemical ingenuity of the plant. And if this unassuming pepper can orchestrate such a complex, interconnected defense network across the jungle floor, what other invisible weapons are currently evolving right beneath our feet, waiting for the next predator to take a bite? The mutations of the predators are now colliding with the chemical thresholds of the plant at an unprecedented pace, meaning the next phase of this warfare will change the jungle's genetic hierarchy forever. The code has been breached, the defenses are shifting, and right now, beneath the damp soil, the next generation of biological weapons is silently calibrating its payload.